conditional probability. We've done basic probability. We've done odds. Now we're going to talk about what happens if I have two events, but one depends on the other. You know, what if this happens? So it's different than when I like flip a coin and draw a card. Those are two separate things. I still can figure out what the chances or my probability of having both of those things occur is, but one doesn't necessarily depend on the other. Here, this is going to make a little bit of a difference. So, conditional probability, definition-wise, is event B occurs given that event A already has. Okay? So, and then they have this funky way of representing it, this probability of B/A. So, our example up at the top, pretty straightforward. Okay, Naomi's playing a game with the spinner shown. What's the probability that the spinner lands on 7, given that Naomi has spun a number greater than 5? Now, again, I'm going to show you the technical way of looking at this, but then we're going to use a little common sense and go, oh, this really isn't that hard. Okay? So, for instance, okay, my probability here, okay, 3 of the 8 outcomes are greater than 5. So, event A is that she spun a number greater than 5. I like to call this the given value. Whatever is told that you are given, that's your first event. Okay? We have to assume that event happens so I can even have the second event occur. So then I look and I say, okay, so that was given Naomi has spun a number greater than 5. Well, there are 3 of those, 6, 7, and 8. So that's where 3 out of 8 would come from for my probability of A. So then I look and I say, okay, so what's my end result? What am I hoping to have happen next if that happens? What's the probability the spinner lands on 7? Okay, that would be my end result. So I have to look and say, okay, the spinner lands on 7. Well, 1 out of 8 chances. Because if I use a little common sense and look at the spinner, there's only one place that the spinner can land on 7. Okay? So there's 1 out of 8 that those two things can occur. And what ends up happening, and I apologize, that should be the probability of A, not the probability of B, is that you just divide those. So here's how this works every time. You're going to take whatever you want to happen at the very end, okay, my end result, and I'm going to divide it by the given value. That'll work, okay? Now, what you're going to start seeing is a little common sense would work too on this, but, you know. So, for instance, here, my end result of the spinner landing on a 7 was 1 out of 8. And my given value, okay, given that the number was greater than 5. Well, we said that's 6, 7, or 8. So that would be dividing by 3 out of 8. But of course, we remember, right, whenever I'm dividing by a fraction, really I'm multiplying by its reciprocal. So 1/8 times 8 over 3. And you can either multiply across or you can just cancel stuff right away. It's like my 8's cancel, and it's 1 out of 3. But let's think about that for a minute. Let's see if we can simplify this. So given she spun a number greater than 5, 6, 7, or 8, okay,
how many chances are getting a 7? Oh.
There's only 3 options there to begin with. And out of those 3 options, how many of them can be a 7? 1 out of 3. Okay? You don't have to go through all of this. I want you to see how you could if you get stuck sometime going, well, I can't kind of get my head around how this works. You can do it in separate pieces and you'll get to an answer. And the more practice you get, the better you'll get at it. But I want you to use common sense when you can on these. So, on these next couple, I'm still going to show you the form, but then we'll also talk about, oh, well, common sense, duh. I mean, how does this work? So, for instance, okay, let's know what the answer is ahead of time. All right. Given that an ace is drawn, how many aces are in a deck?
4.
4. What's the chances that that ace is going to be a heart? 1 out of 4. Okay? So before we even start, we know what the answer is. And if this was a regular question on something, I don't care if you just go straight to 1/4 right away. That's fine. But let's think about it. Okay, here's my magic word given. So given an ace is drawn, okay, an ace is being drawn would be 4 out of 52 or 1/13. And then my chances of the card being a heart, how many hearts are there in a deck?
16.
13. Okay. 13 out of 52 or 1 out of 4. Now we'll come back to that in a minute. Here's what I want you to think about. Okay, my given value is what I'm going to divide by. Okay, that's 1/13. Now remember, your end result takes everything into consideration. So what's the chance that my card drawn is an ace of hearts?
1 out of 52.
Okay. 1 out of 52. Because what I'm actually asking you is, what's the probability of getting the ace of hearts, my end result, because given it's an ace, that the card will come in heart, over the chances of getting any general ace, which is 1 out of 13. Because if I do that, again, I flip or take the reciprocal, and if I reduce the 13 over 52, I get the 1/4 that I knew with a little common sense back at the beginning I was going to get. So it's taking it in pieces. It's taking that end result, you know, if this happens, then this does, to figure out what your numerator is going to be. And basically, we're running into something somewhat similar on the next one, but let's think about this for a minute. Given that you get a club, what's your chances it'll be the 6 of clubs? Okay? Because there's 13 clubs, and the chances, your probability of getting any one card is going to be 1 out of 13. Now let's see where that comes from. Again, here's my given. We're given that a club is drawn, and we're always going to be dividing by that. So my chances of getting a club, but then my end result is getting the 6 of clubs. So I do each of those things separately. I go, okay, my chances of getting a club are 1 out of 13. Or did I just say that right? Hardy. No, Hardy. No. 1 out of 4. I was thinking 13 out of 52 when I put the two things together. My club is 1/4, my apologies. What's my chances of getting the 6 of clubs? Yeah, if you're just drawing from the deck, the chances of getting the 6 of clubs is 1 out of 52. 1/4, because I boneheaded and tried to combine two things too fast. So I go, okay, again, if I'm working this out, 1 over 52 divided by 1/4, I flip it, and then I just multiply my way across. 4 out of 52. Holy moly, Hardy. You got to quit looking at different things and thinking ahead. And there's my 1/13 that I knew I was going to get. So again, if you just can kind of work your way around it and wrap your head around doing it separately, that's cool. Otherwise, what you try to get at the end over what's given. So let's see here. Number 3, let's see if we can do this one with some common sense. The card is a spade, given that a black card is drawn. So black cards are clubs or spades. And what's my chances? We'll come back here in a minute. Let's think about this. All right, given that a black card is drawn. Okay, so let's think about this, okay? So we're looking at a black card being drawn, which is 1/2, because again, half the cards are black, half the cards are red. And then my end result is getting a spade. What's my chances of getting a spade when I draw a card?
1/4.
1/4, because there's 4 suits. And again, if I take my denominator and I take its reciprocal, multiply across, whoa, my chances of getting that card are going to be 1 out of 2, which makes sense because if I have a black card, half the black cards are going to be spades, half the black cards are going to be clubs. So it would make sense that my chances of getting a spade would be 1 out of 2. Now talk to me here. Anything going badly so far? Because the big thing you've got to remember with this, let me bring this back down for a second, okay, is if you take whatever's after that word given and deal with that first, okay, that's always going to be your denominator. And what you're trying to get at the end, which doesn't make a whole lot of sense, you're like, but that's at the beginning. Right. It's what's the chances of those two things going together? So sort of like before when we'd say it was red and it was a queen and we'd add and then we'd subtract what the overlap was. It's kind of the same idea here now that we're working with. They're like, we'll see.
Wait, number 4 is 1/6 of 1/2.
Okay, let's see. I think we may be onto something. Okay, I'm rolling a die now. What's my chances that I'm going to get an even? Okay, my chances of getting an even are 1/2. When I roll a die, what's my chances of getting a 4? So I go, okay. Take the reciprocal of my denominator or flip it.
Plus, you said 1/3.
1/3. Now let's think about this for a minute. Given that the roll is even, okay, there's 3 options. It could be 2, 4, or 6. So given that that occurs, the chances of getting a 4 is 1 out of 3. Okay? So again, if you can think about it that way, go to that. And if you're not sure, be like, Let's see if we can get these last two with a little reasoning. All right. Given that the roll is less than 6, which means it's 1, 2, 3, 4, or 5, what's my chances of getting a 2? 1 out of 5. There's 5 opportunities. I want to know, how can I get the 2? So reading into these is a very good way at being able to simplify things. I'm actually trying to help you find a shortcut instead of having to do everything mathematically, but it's good to have as a backup plan. And then write 6, an even number is rolled given that the roll is 3 or 4. Well, how many of those numbers are even? 1 out of 2. So this is one of those situations I don't want you memorizing some form just because you have to memorize it. I want you having it as a backup plan in case your common sense kind of disappears on you for a minute. We never want that to happen, but just in case. Any issues so far? They're like, no, besides it's Monday morning, everything else is great. All right. Contingency tables. We've played with a form of these before.
Oh, that one's
So now, we've got different possible outcomes, and we can take it according to what happens to be in the table. So for instance, here they said, find the probability that a student plays lacrosse given that the student is a junior. So now, again, to me, this is more of a common sense type of thing. I look at this and I'm like, okay, juniors that play lacrosse, there's 34 of them. How many juniors total are there?
5, 10.
No. Yes, there's 544 total juniors. Now, if you look at using the correct form, which I'll talk about where this came from in a minute, notice, 34 out of 544. And then I just reduce it. Except the fact that that's not 1/6, it's 1/16. But that's how when I'm trying to talk about with common sense, that's what I'm talking about. If you can just do it with common sense, do it. Now, otherwise, we could keep doing this like we were doing the other ones. Because here's the given part. Given the student is a junior, so I'd be looking at a junior over a junior lacrosse player. But again, why do I want to go through? Because now you're looking and you're going, so I'd have to do each one of those. Yeah. Not only would I have to do junior lacrosse players, you do that over the grand total of all the students. So you'd have to add up all of these students
21.8.
and then sit there and go, okay, I'm going to divide by the probability that you're even a junior. And you're sitting here going, why am I having to go through all of this complexity, knowing that what's going to happen when I get to this point is I'm going to take the reciprocal of my probability of being a junior. Those are going to cancel, and we're right back to what we talked about here at the start. Well, I knew 34 played lacrosse. I knew there were 544 total, and I can get the probability. Okay? It's a lot simpler to use the common sense approach here, but that's where it's coming from. So, with that in mind, let's try to use a little common sense here on these two below, and then I'll let you loose. So, all right, the table shows attendance at a wedding. Find the probability that a person can attend the wedding.
They gave you the wrong answer.
What's that?
For the example, probability that a student played lacrosse given that the student is a junior is 1/16.
And that's off?
Oh, my bad.
Oh, okay. I was going to say, what? Yeah, I agree. It's 1/16. So find the probability that the person can attend the wedding given the person is in the bride's family. Okay, so how many people would be able to attend
104.
that are in the bride's family? Okay, 104. Because we're looking for the probability that they can attend and that they're in the bride's family. How many total people are coming from the bride's family or we wanted to attend? 136. And all I would do from there is reduce the fraction, and I'd be good. Okay, the probability would be 13/17. Now, I could, if I wanted to go back through all of this, take my number that can attend over everybody and take my number that are in the bride's family over everybody and go through all that work. But again, just looking at the table and using a little bit of logic makes this easier. So let's make it easier. And finally, all right, table shows the number of students who play baseball. Find the probability that a student plays baseball given that they are a senior. So how many seniors play baseball?
30. Wow.
Okay. So that's the end result that I'm shooting for. And then how many seniors are there? 340. So it looks to me like there's about a 1 in 10 shot that if you're a senior, you're playing baseball. Keep it simple. So I'm not going to worry about that last one because it's kind of getting repetitive at this point. So here's what I need you to do. Oh.
Here's just the worksheet.
6 problems, okay, working with conditional probability, and then if you choose to be working on the permutation and combination extra credit, probably a good idea, because we're going to stick with conditional probability tomorrow, and then we're going to build one more time, and then we should start being able to tone it in here towards the unit test. So that's our deal. And again, this week's schedule's back to normal. I'm here daily in the morning, and after school I'm here Tuesday and Thursday. So if anything's bugging you, we'll see you then.